Hello, I'm Nick Langevin, and today I want to talk to you about a topic we've discussed at length in class, and that is banded iron formations. Banded iron formation is a sedimentary rock composed of alternating layers of iron-rich material as well as a very fine-grained silica precipitate known as chert. Here is a sequence of banded iron formation. The red arrow shows a chert layer in this example, and here the arrow points to an iron-rich layer in the sequence. Note that the iron-rich layer is not always red and the chert layer is not always gray. Quite often these colors are actually switched, but in this example, the red is the iron-bearing layer. So how do we get banded iron formations? First off, there are two main types of banded iron formations. The first, and found over a wider area, is known as superior type banded iron formation. These were created when early bacteria produced oxygen through photosynthesis. This oxygen would react with the free iron in our early oceans to form iron oxide or rust. The iron oxide would precipitate to the ocean floor and accumulate in a layer. Once the water becomes iron poor, silica becomes the most prevalent molecule. This silica then begins to precipitate to the ocean floor. This is how we form the layers of chert we see in the banded iron formation sequence. Here we see a cross-section of an ancient sea. In ancient oceans, the water had an abundance of free iron dissolved in the water due to weathering of iron-bearing rock on terrestrial surfaces. The formation of the earliest photosynthesizing organisms, known as stromatolites, marked the beginning of the formation of superior-type banded iron. These stromatolites produced oxygen through photosynthesis, which would then react with the free iron in the oceans to form iron oxide. This iron oxide would then precipitate to the ocean floor, where it would accumulate in layers anywhere from half a centimeter to 2 centimeters thick. Just as I mentioned earlier, once the abundance of free iron was taken from the seawater, silica becomes dominant in deeper water. Closer to shore, larger grained silt and sand would become prevalent and be constantly settling. This is how we get the cherty and slaty iron formations found throughout the Anamiki Basin today. With the slaty iron formations having formed closer to shore, shown here with the blue arrows, and the cherty silica-based iron formations formed in the deeper water, shown with the yellow arrows. The second type of banded iron formation is known as the algoma-type banded iron formation. These algoma iron formations formed over a much wider period of time, ranging from 3.8 billion years ago to just 400 million years ago. The algoma-type banded iron formation is formed by the degassing of volcanoes under the water surface. This is what allowed algoma-type iron formations to be created so long prior to photosynthesizing organisms. Here we see a cross-section of an ancient volcano in the ocean. Note that once again there is an abundance of free iron in the water. The volcano has small vents that release gases around the base and cone of the volcano. Among these gases is oxygen. This oxygen reacts with the free iron in the water to once again form iron oxide. The iron oxide precipitates to the ocean floor and accumulates in iron-rich layers on the seafloor. Just like the previous example, silica is also present in the seawater, and once most of the iron is taken from the water, the silica becomes dominant and begins to precipitate to the seafloor, where it accumulates in layers of chert as shown here. The same sequence of building iron-rich layers and chert layers continues for millions or even billions of years, creating the beautiful iron formations we see today. I have just discussed the two types of banded iron formations, so what are some of the differences between the two? First, algoma-type iron formations formed over a much longer period of time, nearly 3.5 billion years. Also, algoma-type iron formations are only created near volcanism, and the laminations or layers are very poor compared to the superior-type banded iron formations. As for the superior type, they were only created for 900 million years. The laminations are remarkable, as some layers have been traced for over 300 feet. Also, superior-type iron formations were created over a much wider area than algoma-type iron formations. This is because superior-type formations were not bound to the proximity of volcanism. And finally, the superior-type iron formations are the most commonly mined iron formations today, especially in Minnesota. Thank you for watching, and I hope this helped your understanding of banded iron formations.